Hi guys, let's look at the next question. The next question is question number 4. In parallelogram ABCD, AP bisects angle A, which means if this is X and this is also X, similarly BQ bisects angle B, which means if this is Y, this is also Y. We need to prove AQ and BP, which means I will have to look at this triangle somehow, this one, and I'll have to look at APB. Okay, and then PQ is equal to CD. Okay, so let me join PQ and CD. PQ also, I'll have to prove that PQ is equal to CD, which means if I can prove PQ is equal to AB, then I should be able to prove it. Okay, so let's look at what we can do. Let's look at these two triangles. So in triangle AQP and triangle ABP, let's draw a rough diagram. It'll help us understand the question better, or the diagram better. So this is QAB and this is ABP. What I know is this side and this side are equal. This is the common side. This is 2x. This is 2y. If QAP is x, which means BPA, which means this angle will also be x, because these are alternate angles. Similarly, if I look at CB and AD as parallel lines, if this angle is y, which is QBC is y, then AQB will also be y. So angle Q in this case is y, this angle is y, this angle is x, this angle is x. Let's just write that down. So number 1 is angle QAP is equal to angle BAP is equal to angle QAB upon 2 is equal to x. Perfect. Number 2 is angle ABQ is equal to angle PBQ is equal to angle PBA upon 2 is equal to y. Since BQ bisects angle B and AP bisects angle A. So these two angles are equal. So this is equal. Next. So this is something that we've got. Let's look at number 3. So now in triangle ABQ, what we have is angle ABQ is equal to angle BQA is equal to y. Right. Why is this equal to this? Let's look at this, because since angle PBA is equal to angle AQB, this is alternate angles are equal. So these are two alternate angles, so this is equal, which means this is y. Let's look at the other triangle, but before that let's write that down. Therefore triangle ABQ is isosceles, and that's my number 4, and which gives me AQ is equal to AB. Done. Let's see if we can get similar thing from the other triangle. So in triangle ABP, number 6 would be angle BAP is equal to angle BPA is equal to x. Since angle BPA is equal to angle QAP, these are alternate angles are equal. So I've got this angle and this angle equal. Again, therefore triangle ABP is isosceles. That's number 7, which gives me AB is equal to BP. So from 5 and 8 we get number 9, which is AQ is equal to BP. This is what they wanted us to prove. So this is part 1, hence proved. Done. This part is done. Let's look at PQ is equal to CD. So can we look at something else? This and this is equal. I need to prove that this is parallelogram. Let's look at this big line. Okay, so number 10, AD is equal to BC, which is opposite sides of parallelogram. So subtract 9 from 10. If I subtract, what do I get? Number 11 would be AD minus AQ is equal to BC minus BP, which gives me AD minus AQ is QD and BC minus BP is CP, which means CD and CP and QD are equal. Since QD equal to CP and QD parallel to CP, therefore quadrilateral PCDQ is a parallelogram. Perfect. So what this means is, this is point number 13. What it means is, therefore PQ is equal to CD. That's what we've proven. Why is this equal? Because this part and this part are equal, and in any case they are parallel. Now that part is done. The third part being ABPQ is a parallelogram. So AB number 15 would be ABAQ is parallel to BP, which is given, and number 16 AQ is equal to BP from 9. Therefore quadrilateral ABPQ is also a parallelogram. Done. Interesting question. First we proved through alternate angles and bisector of angles that these two triangles are isosceles. That's how we were able to prove that AQ and BP are equal. Good. Let's look at the next question. The next question that we're doing is question number 5. Question number 5 says, in parallelogram ABCD, there's a diagram given. We need to prove that AB is equal to AB is equal to 2 times BC, and these two angles are given equal. So let this be X, which means this will also be X. This is Y, so this will also be Y. So let's just write. Number 1, let angle DAE is equal to angle BAE is equal to X. Number 2 would be, let angle ABE is equal to angle CBE is equal to Y. Now, how does it help me? This is also given that this side given equal. No, sides are not given equal, sorry. So this side and this side are equal. Number 3 is AD is equal to BC, and number 4 is AB is equal to CD. This is opposite sides of a parallelogram. Perfect. So how do we get this now? In this angle and this angle will be equal because these are alternate angles, and this angle will be equal because these are alternate angles. So let's just write that down. Number 5 would be angle BAE is equal to angle AED is equal to X. These are alternate angles. Therefore triangle ADE is isosceles. What it means is, therefore point number 6 would be, therefore AD is equal to DE. So AD and DE are equal. Okay, so we've got one part, and DE and BC are also equal because this is it. Let's look at the other one. Number 7, angle ABE is equal to angle CEB is equal to Y. Again, alternate angles are equal. I am referring to this angle and this angle being equal because CD is parallel to AB and this is the transversal. So these are alternate angles. Perfect. So that gives me number 8, which is therefore triangle BEC is isosceles, which means number 9 BC is equal to CE. Now I put a single line for BC, so CE will also be a single line. So let's look at from 6 and 9 and 3. What we get is AD is equal to BC, but AD is equal to DE and BC is equal to CE. Perfect. So we've got all four sides are equal. Now we need to prove AB is equal to BC. What we know is AB is equal to DE plus CE. This is from 4 because these are opposite sides of a parallelogram, which means AB is equal to, instead of DE, I can write BC, and instead of CE, I can also write BC from number 10. Therefore, AB is equal to 2 times BC. Done. Anything else in this question? No, that's about it. Good. Let's move on. Let's look at the next question. The next question that we're doing is question number 11. Let's look at question number 11. In parallelogram ABCD, similar question, exactly similar question, but here different things are given. So in parallelogram ABCD, prove that AP bisects angle A. Earlier this was given as a bisector and these two were equal. We had to prove them equal. Now we need to prove that this is a bisector. So let's look at this and see how we can solve this. So in triangle ADP, number 1, AD is equal to DP. Therefore, triangle ADP is isosceles. What it means is angle DAP is equal to angle DPA is equal to X. So let's call it X. Perfect. Now if this is X, this also is X because these are alternate angles. So let's write it down. Therefore, angle DPA is equal to angle BAP is equal to X. Alternate angles are equal. Done. So since from 4, since angle DAP is equal to angle BAP is equal to X, from 2 and 3, therefore AP bisects angle A. Done. This is the first part that they wanted us to prove. Done. We can do a similar thing for the next triangle, which is CPP. Now AD will always be equal to CB because this is a parallelogram. So let's write that down. Since ABCD is a parallelogram, therefore AD is equal to BC. Number 7, therefore triangle CPB is isosceles. What it means is angle CPB is equal to angle CBP is equal to Y. So this angle is Y, this angle is also Y. Number 9, angle CPB is equal to angle ABP is equal to Y. Because again these are alternate angles. This angle and this angle are alternate angles. Alternate angles are equal. So what it means is this is also a bisector. Let's just write that down. Since angle CBP is equal to angle ABP is equal to Y, we got this from 8 and 9. Therefore BP bisects angle B. This is also done. Let's look at the last part. How will we prove angle DAP? So X and CBP Y is equal to angle APB. We need to prove that this is equal to X plus Y. Okay, so let's see number 11. Angle A plus angle B is equal to 180 degree. Why? Sum of co-interior angles. Angle A is given as 2x, angle B is 2y, because we got this as y, is equal to 180 degree, which means x plus y is equal to 90 degree. So this x plus y is 90 degree. In triangle ABP, we get x plus y plus angle ABP. This is point number 13. This is point number 14 is equal to 180 degree, which means angle ABP is equal to 180 degree minus 90 degree. Since x plus y is equal to 90, therefore angle ABP is equal to 90 degree, which is equal to so angle ABP is what we got this as. So number 17 would be angle ABP is equal to 90 degree is equal to x, which is what is they want, which is angle DAP plus angle CBP, which is y. Perfect, because we got this is DAP is x and this is y. For our reference, we've written this is x and this is y, and we got ABP is equal to 90, which is equal to x plus y. Perfect. Again, an interesting question. Let's look at the next one. Next one would be question number 14. Yes, question number, no, not 14, question number 12. So ABCD is a square, and we need to prove that A is joined to point P, B is joined to prove that ABD are perpendicular to each other. So let's just draw a rough diagram first and see how it looks. So that's my square. Here we're saying A is, so let's just mark it first, A, B, C and D. A is joined to a point on BC, which is point P, something like this. Okay, and this is point P, and D is joined to a point Q on AB from here, something like this. Okay, Q. If AP is equal to DQ, so first all these four sides are equal. Next, AP and DQ are equal. Okay, prove that AP and DQ are perpendicular to each other. So we need to prove that this is a perpendicular. Perfect. So let's see how we can solve this. Let's look at, and we know that the base angles are, or vertex angles are 90 degree. So let's look at these two triangles, triangle DAQ and PBA. So in triangle DAQ and triangle PBA, let me draw these two diagonals triangles separately so it's easier for us to understand. So this is triangle ADQ and this is BPA. Angle A is 90, angle B is 90, AD is equal to AB because sides of the same parallelogram, same square, and DQ is given equal to AP. So can I prove them congruent? Yes, this will be right angle, hypotenuse and side. So I can prove these two triangles congruent. So let's just write that down and see how would it help us. Next, number 1 would be angle DAQ is equal to angle ABP is equal to 90 degree. Vertex angles of a square. Next would be hypotenuse DQ is equal to hypotenuse AP. This is given. And then the last is AD is equal to AB, sides of the same square. Done. Therefore, by RHS test, triangle ADQ is congruent to triangle BAP. So ADQ is congruent to triangle BAP. What does this help? What does this give us? This gives us that this angle and this angle are equal. Let's just write that down. In terms of CPCTC, it will tell us that this angle Q, which is DQA, will be equal to APB. Perfect. So if this is X, this will also be X. Let's just mark this down. DQA is equal to X and APB is also equal to X. Similarly, if I take angle D as Y, which means if I'm taking angle ADQ as Y, then angle BAP will also be Y. So DAQ is Y, so BAP is also Y. Does it help me with something? Let's see. And it also gives me that this angle is equal to the other angle DQA. Okay, so let's just write that down in ABP. Okay, so let's just write that down. Number 5 would be angle ADQ is equal to angle BAP is equal to Y. Okay, this is CPCTC, and the last one would be angle AQD is equal to angle BPA is equal to X. This is CPCTC. Does it help us? Hopefully it does. Let's look at this triangle. In triangle ABP, so we are looking at triangle ABP, X plus Y plus 90 degree is equal to 180 degree. We can look at whichever triangle. I looked at ABP, X plus Y plus 90 degree is equal to 180 degree. What it means is X plus Y is equal to 90 degree. Done. This is angle sum property. Let this point of intersection be point O. So, okay. Number 9, let AP intersect DQ at O. So let's look at triangle AOQ. In triangle AOQ, number 10 would be X plus Y plus triangle plus angle AOQ is equal to 180 degree. Again, angle sum property. What it means is angle AOQ is equal to 180 degree minus 90 degree. Therefore, angle AOQ is equal to 90 degree. This is since X plus Y is equal to 90 degree, which means this angle is 90. Similarly, this angle is 90, this angle is 90, and this angle is 90, which means these are perpendicular to each other. So since angle of intersection is 90 degree, therefore AP and DQ are perpendicular to each other. Perfect. I hope you've realized that a lot of these questions involve 2x plus 2y is equal to 180 degree. That's a similar thing that we did here. Here we obviously did not do 2x plus 2y, but we realized x plus y is equal to 90, which means this angle would be 90. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.